Hello, today we're going to learn about the rock cycle. We're going to be revisiting that learning target. So if you could please go to joinpd.com and type in LCDMW. If you could please do that. Thank you. We're going to go ahead and look at the rock cycle. You can follow along with me, take some good notes. You'll have access to this presentation when we're finished. And hopefully if you have any questions, you'll be able to get those answered as well. Your learning target is that I can understand how metamorphic, igneous, and sedimentary rocks are formed through the rock cycle. Let's take that apart. I can understand how, go ahead and say that, metamorphic, igneous, and sedimentary rocks are formed through the rock cycle. Let's repeat after me one more time. I can understand how metamorphic, igneous, and sedimentary rocks are formed through the rock cycle. Let's put it all together and say it together. I can understand how metamorphic, igneous, and sedimentary rocks are formed through the rock cycle. All right. When we finish, hopefully you can understand how metamorphic, igneous, and sedimentary rocks are formed through the rock cycle. Your essential question, the question you need to answer by the end of this: what processes are involved in the formation and classification of metamorphic, sedimentary, and igneous rocks? Go ahead and draw, type. You can even speak to text 2 things you already know about the rock cycle. I can see some of you understand that that the water cycle is a cycle. Some of you say because you never run out of rocks, that it is never ending. So some of you are having a good understanding about what the rock cycle is, what a cycle is. The rock cycle specifically is a model that describes the formation, breakdown, and reformation of a rock. You have sediments, which are little itty bitty pieces of rock. Those little itty bitty pieces, like sand and pebbles, they get compacted and cemented together and they create sedimentary rocks. Your sedimentary rocks then can undergo heat and pressure and create a metamorphic rock. Your metamorphic rock might break into little pieces again, and your metamorphic rock is going to have more layers like this one. It could break into pieces, little sediments, become a sedimentary rock again, or it could undergo heat and pressure and then go deeper and deeper and become magma and become an igneous rock as that magma comes out as lava in a volcano. And then that igneous rock is going to be cooled and hardened, magma and lava, and that can break into little sediments again, and it goes on, and the cycle just keeps repeating. The way that I'll know that you understand this at the end of the lesson is going to be by you being able to replicate this diagram with some keywords showing what happens at each stage of the cycle. Why is it called a rock cycle? I'm seeing some more clear understanding that it's the rock cycle because it goes around and around and never ends, that the different rocks can change into each other. You're having some good clarification about what the rock cycle is and why it is called a rock cycle. Sedimentary rocks. Sedimentary rocks are formed when small sediments are deposited in layers and they're compacted and crushed tightly together. Pretend like the starburst is a rock, and wind and rain and ice cause the different rocks to be broken into little pieces. That's your weathering. And then you have erosion, wind, ice, rain. Those things are going to cause the little sediments to move. Those little sediments are then going to get dropped off or deposited in a new place. As they're dropped off and deposited, they are under layers of different earth and different rocks, so they get compacted together. They get compacted, which means they're getting crushed and packed tightly. And then over time, they get glued and cemented together to form a sedimentary rock. Compaction occurs when those sediments are pressed together and packed down by gravity and the pressure of overlaying rock layers. And then the cementation occurs when compacted sediments stick together and turn into a rock. How are rocks broken down? We just talked about weathering, erosion, and deposition. I call that WED. The sedimentary rocks are weathered. That means they are broken down. Go ahead and make a W with your fingers and show the weathering, the breaking down from rain, wind, and ice. Then those sediments are carried due to wind, water, gravity, and ice. Erosion due to wind, water, gravity, and ice. And then they're deposited in layers and dropped off. So let's do this together. Weathering is the breaking down. Erosion is the moving of sediments. And deposition is the dropping off. That's how the sediments are formed, and then the sedimentary rock is formed when those deposited pieces of rock get cemented and compacted and cemented together. So go ahead and answer true or false. Metamorphic rock. You have your sedimentary rock, and that sedimentary rock undergoes heat and pressure over time, and it becomes a metamorphic rock. It's going to have layers such as gneiss, marble, and slate. And so because of that heat and pressure, while it's buried deep below Earth's surface, it will have layers, very specific layers that you can see. The heat is caused from magma. The temperatures are high enough to change its structure, but not to melt it. And then that heat can change sedimentary, igneous, or another metamorphic rock into metamorphic rocks. The pressure is caused from the intense collision or that friction of the tectonic plates that we've talked about, and then pressure from the overlying rock layers. It's happening deep under Earth's surface, and that pressure, again, can change the sedimentary, igneous, or other metamorphic rocks into metamorphic rocks. What are two things that are needed for metamorphic rocks? If you could just move your cursor. It looks like you're all understanding heat and pressure. Igneous rock is the third type of rock that we have, and it's formed when lava or magma hardened. It's found near volcanoes. This is a volcanic rock, such as basalt, obsidian, and granite. That happens when you have your metamorphic rock. Your metamorphic rock gets buried deeper and deeper and deeper, and as it doesn't melt, but as it heats up and it starts to melt, it becomes molten rock or magma that's reached the surface of Earth through volcanic action. It's characterized by small crystals due to the rapid cooling on Earth's surface. So your metamorphic rock then does melt as it goes deeper and deeper. That melting is caused by the increase in temperature in the rock that's deep below the Earth's surface, the lava, the molten rock material on Earth's surface, and the magma, which is the molten rock under Earth's surface. There's friction between crustal plates, and then that lava and that magma, it turns solid again, and as that happens, the slow cooling that's below the Earth's surface as magma cools, forming large crystals such as granite, or fast cooling happens, and then you get smaller crystals such as obsidian, basalt, and pumice. So if I were to heat this up and melt it, it would crystallize. Some of you have probably seen or explored with melted sugar before, and you know how that crystallizes. So that's what would happen as it cools. Go ahead and answer true or false. Great job. Let's think about how our understanding of metamorphic, igneous, and sedimentary rocks being formed through the rock cycle, how we feel about that. Let's reflect on our ICAD statement by drawing or typing 2 things you learned in today's lesson. Great. That would be the I do part of the I do, we do, you do. The we do part, I would have students the next day bring their Play-Doh or clay or Starburst or something that they could break apart and smush back together. We would create a graphic organizer. I would have them draw pictures along the way of the Starburst lab as we are doing it together and discussing the vocabulary and how the different rocks cycle into the other rocks. I could possibly set up like a Bunsen burner and model for them what that melting and cooling looks like for the igneous rock, and then show you could break that into pieces again, and you would have sediments that could then become sedimentary rocks. The way I would accommodate the lesson is by having some graphic organizers already pre-made that students could print off, and then the you do part, or the they do part, would be a virtual lab that I would have them do, and there would be questions along the way for them to answer to show their understanding as they go. And I would do a formative assessment by having some of them, I would have just draw the diagram, similar to the one at the beginning of the slideshow, adding in compaction and cementation, heat and pressure, cooling and hardening, those different keywords to show their understanding. I would accommodate by having some pre-made graphic organizers that students could print off. I would have speech to text available. I would allow some of them to submit a Google drawing or some type of electronic type of picture. So all different ways for them to show what they know. Resources that I would use, digital resources. I would use BrainPop, Study Jams, Google Slides. I would possibly embed my YouTube video into an Edpuzzle, and then they could answer questions in Edpuzzle as they go along. I would consider using the Ames Rock Cycle booklet that students could create, and then like they could print off at home and create their own booklet, and we could look at that together as another resource. So lots of good resources available for the rock cycle.